Here we are on section 8.6, doing some graphing. And number one, it says find the vertex of the graph for each quadratic. So I'm going to complete the square to find the vertex. So first thing I'm going to do is I'm going to move this plus 7 over here. And remember, we can either move it over here or we can move it to the other side. Of course, if you move it to the other side, it has to be the opposite. And then I'm going to do b over 2 squared to both sides. So my b is 8. 8 divided by 2 is 4. 4 squared is 16. So I'm going to add 16 here. And since I left my 7 on this side to make it equal, I'm going to subtract 16. Plus 16 minus 16 stays the same. Well, these three terms are a perfect squared trinomial, so I'm going to rewrite this as square root of the first term, square root of the last term, sign in front of the middle term, squared, equals 7 minus 16 gives me negative 9. So my vertex is at negative 4, negative 9. Now, if we wanted to, we could go back to our original equation and find the x and y, the x-intercepts and the y-intercepts. Let's do that. If I have f of x equals x squared plus 8x plus 7, and we want to find our intercepts, set that side equal to 0 because the y values on the x-axis are all equal to 0. I'm going to factor this one because it factors nicely into x plus 7 and x plus 1, giving me my x-intercepts at negative 7 and negative 1. Last thing I want to find is my y-intercept, which we know is going to be 7 on the y-axis. Next one. Let's do number 3. If I have f of x is equal to negative x squared plus 10x plus 5, I'm going to do this one the other way where I move my c to the other side just to show you both ways. And I have f of x minus 5 equals negative quantity. I'm factoring the negative out. So I'm going to have x squared minus 10x. And I'm going to find my b over 2 gives me 10 over 2, negative 10 over 2 gives me 5. 5 squared is 25. So I'm going to add 25 to this side. But did I really add 25 when there's a negative in front of the parenthesis? I really subtracted 25. So I'm going to really subtract 25 from the other side. So I get f of x minus 30 equals negative quantity of x 5 minus squared. And then I'm going to add 30 to both sides to get it in the right form. F of x equals negative x minus 5 squared plus 30. So my vertex is at 530 just by completing the square. Now on this one, if we wanted to find our x-intercepts, we would plug it into the quadratic formula. Even though the instructions just asked for the vertex, we certainly could do that. The y-intercept would be 5, of course, because that's the only one without an x. Let's do number 7. 7 has an odd b term, which makes it a little bit different than the others. On this one, I'm just going to move it over again. I showed last example that you can move it to the other side. I'm just going to move it over this time. So when I factor out my negative, I get negative quantity of x squared minus x. If I take half of this and square it, I get 1/4. Half squared is 1/4. And I did not add 1/4. I really subtracted 1/4. So I'm going to add 1/4 to the same side because if you're doing it to the opposite side, you do it the same, but if it's the same side, you do the opposite. So I'm going to add 1/4 to this side to keep it the same. Then I'm going to square root of the first term, square root of the last term, sign in front of the middle term, squared, plus 1 plus 1/4 is 5/4 as a fraction. So my vertex is at 1/2 5/4. X-intercepts, again, you'd probably want to put this into the quadratic formula. Factoring isn't going to work on this one. Your y-intercept is going to be 1 because that's the only number without an x on it. And let's move down to number 11. Number 11 says f of x equals x squared minus 2x minus 3. And we want to find out which of the graphs it looks like. Well, first thing I'm going to do is I'm going to move this minus 3 over here again. I'm going to move it to the other side because I'm trying to do both forms so you guys can see both of them. Notice that when I move it to the other side, it becomes plus 3. Half of this is -1. 1 squared is plus 1. So if I add 1 to this side, I have to add 1 to the other side. So I get f of x plus 4 equals square root of the first term, square root of the last term, sign in front of the middle term. And then I'm going to move this to the other side. So I get this, which gives me a vertex at 1, -4. And if I look at the graphs, the only one that has a vertex at 1, -4 is B. Thank you and good luck.